Your Excellency, Minister Manuel Pulgar Vidal, Madame Maria Luisa Silva, Dr. Ken Takahashi, Ms. Elsa Galarza Contreras, distinguished ladies and gentlemen, I'm delighted to be here, and I'm very grateful for the organizers for having put together this event, because I believe it's going to be crucially important that if we want solutions to the problem of climate change, that the public at large has to be informed, both about the seriousness of the problem as well as the solutions that we have to put together. And I think now the science of climate change, as brought out by the work of the IPCC, is so well established that human society has to take that into account in coming up with a direction that hopefully will not only help the current generation to deal with this enormous challenge, but also assist future generations in being able to lead a life that does not deny them the opportunities which we have. Now, keeping that in mind, I would like to place before you some findings of the fifth assessment report of the IPCC. We have brought out 3 working group reports. The first one deals with the physical science basis of climate change. The second deals with impacts, adaptation, and vulnerability. And the third deals with mitigation of emissions of greenhouse gases, which are really responsible for causing this problem and as an outcome of human activities. So let me start with the very first slide that I wanted to show you. And that's basically the well-known definition about sustainable development, which now is very well known. It essentially says that sustainable development is that form of development which meets the needs of the present generation without compromising on the ability of future generations to meet their own needs. And embedded in this particular definition is the concept of equity, ethics, and the whole opportunity for future generations to be able to enjoy those benefits that we have before us, or we had before us when we came into this world. And therefore, it is our responsibility to see that we pass on to the next generation a similar set of opportunities. Well, this is a quick summary of the extent of effort that goes into the production of IPCC reports. What we present over here is basically the effort that has gone into the production of the fifth assessment report. That's essentially these 3 working group reports. And I don't want to go into all the numbers, but you can see the number of authors who have worked on each of these working group reports, the amount of effort that goes into getting expert reviews, and this is an inherent part of the process that's followed by the IPCC. Every draft is subjected to expert review, and the comments that we receive have to be taken into our account, all of them. And we need to record whether a comment was accepted or not. If it is not accepted, then we also have to record why it is not accepted. So the point I'd like to make is that this is a very open and a very transparent process, and a process in which it's not just the authors who determine the relevance or the value of what has been done, but also a whole range of expert reviewers, and finally governments themselves. The final draft of every report goes to governments for reviews, and they provide from their perspective what they feel is right or wrong with the draft. And of course, we have to take each of those comments into account. And you can see the size of the comments that we receive. In the case of the Working Group 1 report, it was close to 55,000 comments altogether at various stages of the drafting. So it's a very comprehensive and a very thorough exercise on the basis of which we carry out our assessment. And finally, you can look at the number of publications that are cited, because the IPCC works on the basis of published literature, and the number of items of published literature that were reviewed, that were studied, and that were cited is shown in each case. In the case of the Working Group 1 report, it was 9,200 publications that were taken into account. So I'll move on, and I would like to show you the manner in which, on the basis of past observations, we can come to some findings on the nature and extent of climate change. The first diagram over here shows you the changes that have taken place in the ocean in respect of warming of the oceans. And we know now that the oceans have warmed significantly, right down to a depth of 700 meters. And this, as you can imagine, has major implications for marine ecosystems, marine life of various kinds, and as a result, you would also have the migration of species. And I'm saying this particularly because Peru is a country where fishing is a very large part of the livelihoods and occupations of a large number of people. And with the fish stock moving elsewhere because of climate change, clearly there is a direct implication for the lives of a large number of people. The second diagram over here, the one at the bottom, indicates the amount of sea level rise that has taken place on average across the globe. And beginning with the beginning of the last century up to 2010, the increase has been an average of 19 centimeters. And that is quite considerable. And I'll also mention to you in a while what our projections indicate in terms of sea level rise in this particular century. Now, here I'd like to mention that there's a 95% certainty that human influence has been the dominant cause of observed warming since the mid-20th century. This figure is very important because it represents an increase over the last assessment report, which came out in 2007, where we had said that there's a 90% probability of most of the warming having been caused as a result of human actions. And since the 1950s, many of the changes that have occurred are unprecedented over decades to millennia. So you can imagine, in a short period of time, human society has brought about changes that have not occurred for thousands of years, millennia. And limiting climate change, therefore, obviously, will require some major actions and interventions to see that the trend that we have of increasing emissions of greenhouse gases can be changed and preferably reversed. This diagram gives you the sources of emissions of greenhouse gases, and you can see over here electricity production is one major source. AFOLU stands for agriculture, forestry, and land use. And then you have transportation, you have buildings, and you have other sources, industry, for instance. That's in the left-hand side of the diagram. On the right-hand side, you've got indirect emissions, because if you take the case of industry, it's not just what industry produces, but also the inputs that industry requires. Those are also responsible for emissions of greenhouse gases. So therefore, if you have to put together emissions for the entire cycle, then clearly the figure would really represent the sum total of both. However, this gives you an indication of the major sectors where we need to bring down emissions of greenhouse gases if we want to bring about a change in current trends. And essentially, we know that it's economic growth and population growth which contribute to emissions of greenhouse gases. And these are expected to continue to drive emissions unless we bring about some major efforts to arrest this pattern of growth. So here I'd like to go into some observed climate change factors and their impacts as far as Peru is concerned. There's clearly, on the basis of observations, the conclusion that we came to that strong negative precipitation trends and warming are detected in the Mantaro Valley in Peru. So, in other words, water availability in that area is going to be a casualty over a period of time if this trend continues. And air temperature increases in the southern Andes of Peru and in the Peruvian western Amazonia. Mean rainfall for the period 1964 to 2003 has decreased. So that again is an important finding, because clearly that has implications for the people living in that area, since they are going to face a much lower level of precipitation and water availability than would have been the case if there was no climate change. There's also rapid retreat and melting of the tropical Andes glaciers, and this involves Venezuela, Colombia, Ecuador, Peru, and Bolivia. And 7 out of the 9 river basins have probably crossed a critical threshold, exhibiting a decreasing and dry season discharge in the Cordillera Blanca of Peru. So we can say conclusively that the flow in these rivers, 7 of the 9 rivers, is now on a trend whereby it's going to decrease in the future, and there's absolutely no possibility of this being reversed. So it's obviously crossed a certain threshold which would ensure reduction even in the future. There are also extreme events associated with climate change. An increase in heat waves that has been observed over a period of time. And if you look at projections for the future, then it's very likely that the length, frequency, and/or intensity of warm spells or heat waves will increase over most land areas. In fact, under certain scenarios, it can be concluded that those heat waves which currently take place once in 20 years will, by the end of this century, occur once in 2 years. So we need to be prepared to deal with this, and we would need to put in place some adaptation measures to this major change that's going to take place in the future. And by way of adaptation measures, let me give you an example. In 2003, as you would recall, there was a major heat wave in and around Paris and parts of Europe, as a result of which about 40,000 people died. Now, in 2006, there was a somewhat similar level of heat increase and a heat wave. And on that occasion, fortunately, you didn't have anywhere close to that level of casualties. And the reason was that I think those places which were affected were much better prepared to handle the heat wave on that occasion. Even simple things like early warning can make a lot of difference, because people can then take steps by which they protect their health and their lives. So adaptation measures can often be very simple and low cost or low regrets measures, such as early warning systems. There could be other measures also whereby you create or strengthen local institutions that can quickly mobilize people to deal with any such occurrence that takes place. And another extreme event is the increase in the frequency and intensity of extreme precipitation events. In other words, heavy rainfall in a short period of time. And this, under some scenarios, we have found will be the case even in those areas where there's a decline in average rainfall. And in those cases, the bulk of the rainfall is occurring and will continue to occur in the form of heavy falls. Now that also has major implications for risk to people and property, because if you get heavy rainfall in a short period of time, it has the potential of major damage. But even more so, that kind of implication would also apply to our ability to use that water productively. Because if you get a huge amount of rainfall in a short period of time, most of that water will just go as runoff. You really won't be able to utilize it. So it could very well happen that you may get the same amount of rainfall during the year, but since it occurs in very short and heavy spells, then your ability to use that water may be affected adversely. This is just a projection of temperatures that we expect by the end of the century. The IPCC has used 4 different scenarios. The 8.5 scenario, the RCP, representative concentrated pathways as we call them, is a scenario which essentially will give you very high temperatures because it involves a business as usual path with no mitigation efforts at all. So clearly this is a scenario that can lead us, I'm using the word deliberately, to disaster, because you could get temperature increases of up to 4.8 degrees Celsius by the end of this century. And that clearly means that this planet will not be able to encounter that level of temperature increase and all the associated impacts of climate change. On the left side, you have RCP 2.6, which is a very stringent mitigation scenario, and by which we reduce emissions significantly, so much so that by the end of the century we have 0 emissions or actually go into negative emissions. And I'll say a little more about that. Now, with the 3 higher scenarios, as you can see, there's a likelihood that temperature increase by the end of the century will increase 2 degrees Celsius. And it's really the lowest scenario which gives you some degree of optimism that we can deal with climate change and not allow it to go above 2 degrees Celsius. Then sustained mass loss by the ice sheets, some of which are irreversible, would cause larger sea level rise. And I can give you an example of that, the Greenland ice sheet, which is a huge mass of ice on what is the largest island in this world. The only island which is bigger than that is Australia, but Australia is a continent. And if you go to Iceland, it's really a mountain of ice about 3 kilometers high. I've gone there, and of course our plane had to land on skis, not on wheels, because on that ice wheels will probably not work, they would slip. And I remember the plane that we went on, it was a US Air Force plane. Couldn't take off because there was fresh snow on that day, and it had to wait for a while before it solidified and there was ice. Now you can imagine that massive amount of ice, if it was to melt, what it would do to sea level rise. So that's something to be concerned about, and clearly if that were to happen, then that would be an irreversible happening. Sustained warming greater than some threshold, greater than about 1 degree Celsius but less than 4 degrees Celsius global mean warming with respect to the pre-industrial level would lead to near complete loss of the Greenland ice sheet over a millennium or more. So it's not going to happen overnight, but clearly we would be on a disaster pathway, which perhaps in a millennium, that's 1,000 years, would see sea level rise reaching a level of about up to 7 meters. So that clearly is something that we don't want happening to this planet. Now, there would be serious impacts on food security because there would be projected negative impacts on agricultural yields above 2 degrees Celsius based on the threshold, let's say, based on the benchmark of what we have by way of temperatures at the beginning of this century. And there would be redistribution of marine fisheries catch potential. This poses risk of reduced supplies, income and employment. And I mentioned this earlier because for Peru, I'm sure this is a very important consideration. So basically, climate change can have very negative impacts on food security, not only in respect of what we produce on land, but also what we produce from the seas. And there's increased likelihood of injury, disease and death due to more intense heat waves and fires, undernutrition from diminished food production in poor regions, because in poor regions, a large number of farmers are dependent on rain-fed agriculture, and they hardly have surpluses to sell to the market. Most of what they produce is meant for their own consumption. And if that yield is to suffer, then clearly that has major implications for food security and nutrition. Risks from food and water and vector-borne diseases will also increase as a result, because a large number of pests that can cause disease would probably multiply and exist in much larger numbers in larger areas than is the case currently, which poses risks to human health. I would like to also mention that climate change can lead to displacement of people. And you can imagine, if I could give you an example, if there's an area which has water stress, what is going to happen? People will move away from there. Or if agricultural incomes were to decline, food availability was to decline, people will move elsewhere. There are also parts of the world where sea level rise is causing serious problems. A person that I know is the president of Kiribati. It's written as Kiribati but pronounced as Kiribati. This is a small set of islands which form a nation in the South Pacific, and the president of Kiribati informs us that several of his islands have been abandoned because people can't live there. They're living in a state of fear. So there would be displacement of people for a variety of reasons, and that's something to be concerned about. There's also the risk of violent conflict. Again, let's say if there's a river where water flow has reduced and people downstream want more water and those upstream want to impound most of it and make use of it. Clearly that has the potential for conflict, and that obviously would increase over a period of time as climate change becomes worse. And there would be rivalry among states due to potential transboundary impacts of climate change, such as changes in sea ice, shared water resources, and pelagic fish stocks. These are fish stocks out in the sea or in the oceans. What are the risks to urban areas in particular? Well, rising sea levels. You know, a large number of towns and cities are located in coastal areas, so they are very vulnerable to the risk of sea level rise, storm surges, heat stress, extreme precipitation, flooding, landslides, drought, increased aridity, water scarcity, and air pollution. The state of California, I was there less than a month ago with the governor of California and the former governor Arnold Schwarzenegger, and California currently is going through a crisis. They have an acute shortage of water and aridity that they have not experienced in the past. Risks can have widespread negative impacts on people, economies, and ecosystems. And risks are amplified for those who live in informal settlements, those who are living in slums, for instance. And I'll give you an example. In the city of Mumbai in India in 2005, there was a massive cloudburst, a huge amount of rainfall in a very short period of time. The entire city was flooded, and in fact, a few people lost their lives. Now, those who were living in slums had nowhere to go. They were completely flooded, and you can imagine how many of them were displaced. Of course, they came back after a few days and constructed those flimsy urban dwellings, but clearly they were the worst victims of that kind of an extreme event. So those who are living in informal settlements are certainly the most vulnerable. Projected impacts in Peru, 2 to 30% annual discharge decrease in the Santa River once the glaciers are completely melted. Projections estimate impacts of glacier melt to be between US dollars 212 million to US dollars 1.5 billion due to the impacts on hydropower generation. So if water flows are going to change, then obviously hydroelectric power that's designed to be produced will not be produced. And Peru is one of the most vulnerable countries to climate change impacts on fisheries, which I mentioned is taking place already because of migration of fish. And this, of course, is an important input in the national diet of this country. And climate change may alter plant diseases, and potato late blight severity is expected to increase in Peru. So changes in temperature, precipitation have major impacts on a large number of crops that are going to be produced. In fact, we have found that wheat, rice, and maize are particularly vulnerable to the impacts of climate change and therefore of reduced yields as a result. And throughout the 21st century, climate change impacts are projected to slow down economic growth, make poverty reduction more difficult, further erode food security, and prolong existing and create new poverty traps, particularly in urban areas and emerging hotspots of hunger. Here I want to say that these poverty traps are not going to be confined only to the developing countries. You would see them sprout and grow even in developed countries. So this is a universal problem that we all have to be concerned about. Now, impacts of climate change on the financial sector. There would be significant effects on investments by introducing previously unforeseen risks. Climate change will affect all sectors of the economy. Risks are relevant to investors and financial institutions. These include expected reduction in productivity and economic growth, direct physical impacts of climate change, okay, that's gone, thank you. Knock-on effects such as threat to social stability posed by high and volatile food prices. If food prices go up, I mean, you've seen in so many parts of the world when food prices go up, you literally have riots. So clearly this is going to be something that we have to be concerned about. Impacts of policies to reduce greenhouse gas emissions from electricity generation, large industrial sources, transport and other sectors. So obviously all of this has major implications for investments and for the financial sector. Now, unfortunately, if you look at what is happening across the world, the financial sector has not really equipped itself to deal with some of these issues, even though the investments are going to be affected in the future. The one industry that has been very smart in this regard, because it's their bread and butter, is the insurance industry. You know, the chairman of the Bank of America, and he's the former chairman of DuPont in the US, Chad Holliday, told me, and I don't mind sharing this. He said he's got a house on the beach in the state of Delaware, and he says he can't get insurance because the insurance companies tell him that that's very vulnerable, and therefore they're not prepared to insure it. Now, this is something that's going to happen more and more in different parts of the world, simply because the insurance companies are really focused on the risks from climate change. Of course, sea level rise is only one type of risk, but if you look at what happens in Florida, you get storms over there, you get tornadoes, you get all kinds of climate-related events which will influence the risk that insurance and financial institutions would take into account. And overall, in the developing countries, we are very vulnerable to some of these impacts, because if you look at the number of deaths that have taken place between the period 1970 to 2008, 95% of them have, as a result of all kinds of natural disasters, taken place in the developing countries. So we are particularly vulnerable in the developing world. What do we do about this? Well, to deal with the problem, we need climate resilient pathways which involve adaptation to the impacts of climate change and mitigation of emissions of greenhouse gases. Because one or the other will not work. If you only try to adapt to the impacts of climate change, then at a certain stage you will cross thresholds or tipping points beyond which adaptation will not work. At the same time, if you only mitigate, then you're ignoring the fact that the impacts of climate change will continue for several decades into the future, because there's a certain inertia, there's a momentum in the system which will not in any way allow these impacts to go away. So therefore, we really need to build both these strategies into our development plans and policies. Now, the most effective strategies also offer development benefits. Let's say disaster reduction. If a society is well equipped to deal with disasters, it also has major development benefits. Because if people don't have to worry about the impacts of disasters, then they can focus on development issues. I mean, even in the developed world, if you look at Superstorm Sandy, which I'm not saying is the result of climate change, but events of that nature are definitely going to increase in the future. Now, look at the cost of that particular occurrence. It's been several tens of billions of dollars. If you look at Hurricane Katrina, which took place in the city of New Orleans, it completely devastated that city and that state of Louisiana. And the cost of that devastation could be anywhere up to $200 billion. So these are issues that we have to take into account, and therefore there are development benefits in taking some of these measures. The effective risk management and adaptation are tailored to local and regional needs and circumstances. So as distinct from mitigation, where you need a global effort, there's no point in trying to mitigate emissions of greenhouse gases in just one country, because if the others are emitting, then these are gases that mix freely, and therefore the world will not benefit only by one country or one society taking that step. But in the case of adaptation, it's very much a local issue, And therefore, what we need to do is to set up local institutions and create local know-how whereby we can adapt to the impacts of climate change. Adaptation experience in Peru, constitutional and legal reforms that have been taken into account for water resources management in coordination between 7 countries in South America and Central America, including Peru. But of course, further implementation is required, and I think we'll also have to come up with assessment of what the impacts are going to be in the future. And here I'd like to say something particularly for the attention of His Excellency the Minister. We have to create modeling capabilities in countries like Peru and in fact every developing country. And this really requires supercomputers on which you can run climate models, downscale them, and then see what the impacts would be in several distinct parts of a particular country. Because it's only on that basis that you can prepare for the future. And I think this is a capability that in developing countries in particular we have to create rather quickly. Then the management of ENSO-related events in Peru through participatory or risk reduction approaches is very praiseworthy. Crop diversification in the Peruvian Andes to suppress pest outbreaks and pathogen transmission. Then addressing constraints on access to key resources for reducing vulnerability, as shown by studies with indigenous farmers in highland Peru. So, you know, there are a number of adaptation measures which have been taken in hand, but if we want to focus on the future, then we need a much more precise assessment of what these impacts will be in the future to be able to deal with them. Now, in the case of mitigation, you know, often you hear the fact that mitigation will ruin economic growth, will ruin employment opportunities, but that's really not correct. We have assessed what kind of mitigation would be required to limit temperature increase to 2 degrees Celsius by the end of this century. Well, if you look at the line on top, that gives you GDP growth without mitigation. And the line at the bottom gives you GDP growth with mitigation. And if you look at the loss that would occur with mitigation, it's only 1.7% of the global GDP in 2030. Now clearly that's not a high price to pay, because you would be able to avoid some of the worst impacts of climate change through this kind of mitigation. Otherwise, the cost of those impacts, and even some of those impacts which cannot be really monetized, will be so high that it would certainly exceed the 1.7% of the GDP that's shown over here. Essentially, in order to limit temperature increase to 2 degrees Celsius, we'll have to reduce greenhouse gas emissions in 2050 by 40 to 70% over the 2010 value. Emission levels would have to be near zero in gigatons of CO2 equivalent or below in the year 2100. So that means if we want to limit temperature increase to 2 degrees Celsius, then by the end of this century, we will either have to have zero emissions or negative emissions. And that can be done. How? More rapid improvements in energy efficiency, a tripling to nearly a quadrupling of the share of energy supply from renewables by 2050, and you would need widespread deployment of bioenergy, carbon capture and storage, afforestation, and other carbon dioxide reduction technologies post-2050. So you also need a lot of research and development. Carbon capture and storage is one such area, but there could be several others. Even in the case of renewable energy technologies, we need to bring down costs and improve efficiency. That would only happen with research and development at the requisite scale. There are, of course, substantial shifts in annual investment flows during the period 2010 to 2029. So we have to provide policies by which these shifts will actually take place. An annual investment in conventional fossil fuel technologies would decline by about US dollars 30 billion compared to 2010. Annual investment in low carbon electricity supply, that's renewables, nuclear, electricity generation with carbon capture and storage, would rise by about US dollars 147 billion, and annual incremental energy efficiency investments in transport, buildings and industry is projected to increase by about US dollars 336 billion. I mean, quite apart from these numbers, the point that has to be made is that there will be shifts in the way flows of money are going into specific sectors of the economy. It's only then that we would be able to achieve the results that we would like. There are opportunities for the financial sector. Approximately $340 billion was invested in mitigating climate change in 2011-12, with 62% of this provided by the private sector. So anyone who says that business is not doing its part, well, possibly it's not doing enough, but it is clearly making a difference already. Governments will look to the private sector to provide much of the capital. Private finance has a critical role to play in the transition to low carbon economy. And there will be a whole range of co-benefits like higher energy security, enhanced employment and better air quality. But the willingness of private investors and financial institutions to provide this capital will depend on how they view the risks associated with policy and the incentives provided. So this is where I think governments have to come up with policy measures that create a sense of confidence in the private sector, and that would bring about the kinds of investments that would move the country or the globe, a global society in the right direction. One such measure could be a price on carbon. If there is a price on carbon, then business obviously gets a very clear signal, both in respect of investments but also research and development. And this is a point that I'd like to make. Renewable energy technologies are already viable in a number of applications because the yellow band that you see represents the costs of conventional power, and the bars that you have represent the cost of renewable technologies. And in several cases you can see an overlap. That means renewable energy technologies are already competing with conventional fossil fuel based power or energy production. So at least in these areas we can start moving ahead aggressively in a way that will not at all lead to a reduction in economic output. Okay, there are also co-benefits which I mentioned: energy efficiency and higher energy security, cleaner energy sources that would lead to improved air quality and human health, reduced energy and water consumption in urban areas, sustainable agriculture and forestry, because agriculture in particular is being affected by the impacts of climate change, and so also forestry, and protection of ecosystems for carbon storage. One example of that is the peat that you find on the ground, let's say in the rainforests in Indonesia. Now that peat actually absorbs a lot of carbon, and if that's destroyed, then clearly all that carbon will escape into the atmosphere. There are several initiatives that are in hand. Cities in particular are very active. Then there's growing awareness of Central America and South America governments on the need to integrate climate change and future climate risks in their policies. 18 regional non-annexed countries, including Peru, have already published their first and second national communications to the UNFCCC. So the point I'm trying to make is that awareness and the desire to take action is growing worldwide. But of course, we need to move much faster and on a much larger plane. Stable climate is one component of sustainable development. If the climate is going to worsen, then you're not really moving on a path of sustainable development. Designing an effective climate policy involves mainstreaming climate in the design of sustainable development strategies. Behavior, lifestyle, and culture can substantially contribute to lower emissions, and this is where a society like Peruvian society can do a lot. Changes in consumption patterns, dietary changes, reduction in food waste. All of this would have major benefits in terms of reduced emissions of greenhouse gases. And there is an issue of equity and justice which we cannot ignore, because the worst impacts of climate change will be felt by some of the poorest people in the world. And of course, there is differentiation on account of past versus current emissions, varying challenges and circumstances. The small island states have a very different challenge from, let's say, a country like Switzerland. There are different capacity to address mitigation and adaptation. So we have to accept the fact that we're dealing with a challenge which is very unequal in different parts of the world. And equitable outcomes can lead to more effective cooperation. So if we're sensitive to the equity issue, then everybody would feel comfortable and would feel that they should be part of the global effort to deal with climate change. And that certainly will lead to much greater cooperation. And Einstein said that problems can't be solved at the level of awareness that created them. And Mahatma Gandhi said, speed is irrelevant if you're going in the wrong direction. If we are pursuing a path of development that is causing all these problems, and we feel very good about 8 or 9% growth in GDP, clearly that's irrelevant, because if we're going in the wrong direction, let's not measure that as a great achievement. So with this, I'd like to end, and thank you very much for giving me this opportunity.